All right, we're going to talk about momentum. And momentum is that transfer of energy. It includes two variables, mass and velocity. So the formula for momentum is P equals mass times velocity, where P stands for momentum because we can't use M because M stands for mass. So I always think of it as momentum. And the unit is kilograms times meters per second. Now, this should be familiar. We've talked about this a little bit before. We have a video here if you want to go back and look through it, kind of re-explaining this, so it's there for your assistance if you need it. Momentum is a property of moving matter. It describes the tendency of objects to keep going in the same direction with the same speed. So change in momentum really results from forces or creating forces. So the momentum of a ball depends on its mass and velocity. So B, in this case, 1 kilograms times 3 meters per second versus ball A, 1 kilogram times 1 meter per second. Ball B has more momentum because it has a greater speed. So if one of these variables increases, it has to have more than the other. So if this one went to 5 kilogram ball at 1 meter per second, it would then have more momentum than ball B. So you can have one object with different momentums depending on the speed, and you can have the same speed with different momentums if it has different masses. So inertia is another property of mass that resists change in velocity. However, inertia depends only on mass, and that's a difference. Momentum is a property of moving matter that resists change in the object's velocity. Momentum is a vector quantity. Inertia is a scalar quantity if you're really big into math. And when we get into physics, that will make more sense. So momentum of a moving object is mass multiplied by velocity. That means momentum increases with both mass and velocity. I've now said that twice. If one of these two variables, mass or velocity, changes, your momentum changes. Kilograms times meters per second, you literally have to write out kilograms times meters per second. There is no abbreviation for that unit. Law of conservation of momentum states that when a system of interactive objects is not influenced by outside forces like friction, the total momentum of the system cannot change. That's basically saying the law of conservation of energy says you can't create or destroy energy. So law of conservation of momentum basically states that in the absence of outside forces, like if you're in outer space and you push away from the space shuttle and you're not tethered, there's no way for you to change your direction. You will just continue going forever in that direction because there's nothing to slow you down. On Earth, we have friction, so we do slow down, but in the absence of that, you would not. So you need to say that you've gone through the notes. Congratulations, have a great day, and as always, if you need help, ask.